Howdy. Let's start this video off by watching some weather maps, satellite imagery from today. There are so many interesting things going on at the moment, but one of the things that I have found very interesting is this area here. If you zoom in a little bit here, we have England, Ireland, Iceland, and we can see this feature here. And obviously you can see there's something going on because there are no mountains out there in the Atlantic Ocean. Like you have, if you have been told in school that, yeah, that the clouds are smashing into the mountains, that's why it's raining and stuff like that. Yeah, here we don't have any mountains. That would be like, you know, 2, 3, 4, 5,000 meters high. And yet there's still, we can see it, something is staying here. And so I started to take a look around if there's anything. We have to go, let's go first up here to the National Data Buoy Center. Now they told everyone that they don't show those buoys that are not working anymore. Yeah, stations with no data unless they don't show them anymore. And it's rather hard to tell where exactly this is going on. It's south of Iceland and at the northern tip of England. So south of Iceland, northern tip of England. It's somewhere here, I guess. Hatton Bank. Yeah, there's a mountain, but the peak of the mountain is still 459 meters below the sea level. And still, as we just saw on the satellite imagery, something seems to keep the vortex in place. Let's give it a go in order for you to get a grip of this once again. And since we can see the vortex spinning direction is anti-clockwise, applying the right-hand rule on the northern hemisphere, we can determine that the energy is going up towards the heavens. From somewhere here, the Hatton Bank. It doesn't really help when you zoom in because there's nothing really visible here. And here's something here also in the middle. And somewhere here, here it is. Check this out. The Rockall Bank. Yeah, this, I have to admit, this somehow looks artificial to me. We have these kind of shapes, squares, rectangulars, and this one here as well. And that there are like several features here that in a way don't really look natural to me. And there's more stuff here going on. Crossroad. Don't know. Rockall Bank. It's interesting. Maybe it continues even still further here. Hard to say. It's all blurred out. There are some strange straight lines. There might be some remnants of satellite imagery. But I also want to point out that there's like several features like these. They all could be some active geological features. In other words, volcanic in nature. Like all of these quite likely are. Here is a nice one. 77 meters below the sea level. Yeah. But this I found interesting, this area. Hard to say. I couldn't really find any better maps about this. But I found something else interesting, which is located somewhere here. As you can see, you don't see anything, right? There's nothing too interesting here. Nothing really visible. Now let's zoom out a bit. You can see we are still, besides England, or at the inner seas of the west coast of Scotland. All right. The Hebrides Torres Seamount. Maybe it's Terrace. Where is it? Because I found... Yeah, this might be a rather long video. The EMOD net map viewer. So here, that's the inner seas of Scotland. This region, we are looking at this region. Keep in mind this seamount. No, where is it again? Here. So here, we zoom in somewhere here. And that's a different map, obviously. Yeah, check this out. That's interesting too. This doesn't really look natural to me. Because here on the right side we can see the rocks and stuff like that. But then here we have some structures, maybe. Yeah. And now just for comparison, we have the EMOD map viewer here. We are watching this area with these structures. And when we go over to the place where I showed you these other structures, they are not visible on this map. Yeah. So we have to use at least two maps in order to see those both structures. Maybe here's, if you know maybe where to look, you could possibly see something. So here on this side, we have this structure here, or these structures. I might be wrong. Maybe there isn't anything. Maybe that's just some digital remnant of whatever. They are not visible here on this map at all. Nothing to see. But on the other hand, when we go to the other side, let's take a look quickly at these again. Maybe these are some artificial structures. Maybe not. Who knows? There might be a rectangular, here is something, and here we have straight lines. You know? Maybe, maybe not. But that's actually not the real point of this video. I just accidentally found those two places because I was more interested in the actual sea mounts and banks and stuff like that. Because the magnetization of Rosemary Bank Seamount Rockall Throw or Throth Northeast Atlantic, which is this one here somewhere, Rockall Rise. Rosemary Bank is a non-uniformly magnetized seamount in the northern Rockall Throw. The reversely magnetized major component of the anomaly field was simulated by a numerical method and modeled using the Talvani three-dimensional magnetics program. The results suggest a higher Königsberger ratio that earlier reported for Rosemary Bank and a remnant magnetization vector compatible with post-Jurassic formation and probably of late Cretaceous or Tertiary age. The limited depth to the base of the model implies that Rosemary post-dates the underlying basement in agreement with a volcanic origin. The residual of the observed anomaly field is interpreted as being caused by normally magnetized bodies within and on top of the bank. This suggests subsequent volcanic activity during an interval of normal polarity. Yeah. In other words, the Rosemary Bank is a volcano because obviously it erupts every now and then. Rosemary Bank Seamount is located on the axis of the northern Rockall Throw or Trough, Northeast Atlantic. Rockall Trough is thought to be underlain by oceanic crust of Cretaceous age. Yeah, underlain. Yeah, so the seamount is on top of that. Although Russell and Smythe have interpreted a Permian age. In this context, the age of the seamounts in the trough has some importance, for they may have formed in association with the terminal phases of spreading in the trough in either Cretaceous or Permian time. Alternatively, they may be related to the widespread lower tertiary igneous activity associated with rifting and spreading between Greenland and the Rockall Plateau. Although dredging would contribute to this problem, only badly weathered and thus undatable basalts have been obtained from Rosemary Bank. Remember, basalts, the thing about the aluminium, that the difference between clay and lava is basically only the amount of water. Otherwise, it's the same material. This means wherever we have this kind of clay coming out of the ground, the muddy waters, dirty waters that contains clay materials, sediments, it is 100% volcanic in nature. It's just very, very wet lava. So here we have basalts. We are talking about lava, volcanic activity. And also you have to understand that these time Cretaceous or Permian age, these are like so old, many, many millions or even more years old. And hopefully you are aware of the great difficulty or the unreliability of their techniques and stuff in order to date the actual rocks, because they think certain rocks have to be millions or billions of years old due to the stage of the metamorphism and stuff like that. But I probably proved them very, very wrong because I made these microwave experiments and it just takes a few minutes, sometimes even less, in order to get the metamorphosed rock done. So it doesn't need any meteorites or asteroids, nor does any dinosaur have to die, nor does it take billions of years. Just a few minutes in the microwave. And if you think that's crazy, then just think of the rock or the pebble in the microwave as planet Earth, and the microwave itself, the energy source. We could take the sun or the rest of the universe. So there is a lot of energy that can be provided by the sun or the rest of the universe induced into Earth in a very short amount of time. That's why my microwave experiments are so important, and even more important to understand the implications of what they are about. So, back to this. There was something. Basically, I think that's the main point of what I have been trying to tell you regarding to these anomalies, magnetic modeling. So they are basically when they are making these kind of magnetic modelings, we can see that it's like the year rings of a tree. We can determine basically the rhythm of the eruption of those volcanoes because they are volcanoes after all. And I want to bring to your attention once again the Borealis mud volcano. Borealis is a recently discovered submerged mud volcano in the polar North Atlantic. Okay? The release of warm 11.5 degrees Celsius water. I wouldn't consider that too warm. But the thing is, this is very important. Octocorals. There's corals forming here. You know, carbonate, pinnacle, octocorals. They are forming here at the mud volcano because there's stuff coming out of the mud volcano. What do they say about E? Where is it? Georeferenced ROV images show a carbonate pinnacle colonized by Octocoralia. Yeah. Corals. Since a while, I have been thinking that coral reefs might be actual, how to say, they are volcanic in nature. Coral reefs are volcanic in nature. We have to go to this also. First observations of megafaunal communities inhabiting George Blythe Bank, Northeast Atlantic. And that's somewhere here. George Blythe Bank here. George Blythe, however you spell that, I don't care too much about my bad English. Maybe one day I will learn it properly. But anyway, first observations of megafaunal communities inhabiting George Blythe Bank, Northeast Atlantic. Abstract. Let's zoom in a bit. George Blythe Bank, situated at the northeastern end of the Rockall Plateau, forms a part of an extensive system of elevated submarine topography in the UK's exclusive economic zone of the Northeast Atlantic. Through the UK's Strategic Environmental Assessment Programme, these seamounts and offshore banks have only recently been investigated in any detail, allowing the first photographic record of epibenthic megafaunal communities. The results presented here are based on photographic and video observations along 7 transects on George Bly Bank, covering a depth range from 425 to 1,338 meters. Diverse communities of sedentary suspension feeding organisms were observed along 5 of the 7 transects, with some evidence of localized hard coral frameworks. Hard coral frameworks. Community composition on George Bly Bank is similar to those observed in other hard substrata in the deep northeast Atlantic. So now first we are reading the abstract. This paper was made in 2013 or something, if I remember correctly. Yeah, check it out. Almost to the day. Some years ago. You can do the math. But anyway, that's the abstract. So obviously this is made by professionals. And here we have this word, epibenthic. And since I'm a curious person, I wanted to know what epibenthic means. Epibenthos, redirected from epibenthic. The aggregate of organisms living on the sea bottom between low tide and 100, let's zoom in a little bit. The aggregate of organisms living on the sea bottom between low tide and 100 fathoms, 180 meters, okay? Low tide and 180 meters. This is what epibenthic means. Now keep this in mind. Low tide, so it's basically the shore, and 180 meters. When we go back to this paper, they are talking about epibenthic megafaunal communities and a depth range from 425 to 1,338 meters. Low tide 180 meters, 425 to 1,000. So there's something off with this. They shouldn't have used this word because it doesn't match the depth range at all. But maybe the most important takeaway from this is that we have hard corals. Introduction. Seamounts and banks are prominent features, often with a rocky substratum, rising up generally from the surrounding soft sediment seabed. The seamounts and banks can differ in shape and size as well as summit depth and location. The term seamount is generally restricted to features over 1,000 meters in height. Submarine banks have lower elevations of 500 to 1,000 meters. Estimates of the number of seamounts based on the above definition vary. Some estimates are as great as 100,000. Whereas Jessen et al. Have identified only 33,000 seamounts. Using global bathymetric data at 30 arc seconds resolution. The number of banks is even greater, predicted 140,000 banks in the world's ocean. Of these, fewer than 300 seamounts have been studied in any detail, less than 1% of the overall total. The proportion of banks studied is even lower. Seamounts were viewed initially as insular environments with high rates of species endemism and as hotspots of biodiversity and biomass. More recently, new research has found that, contrary to most of these ideas, seamounts tend to have comparable levels of species richness and similar communities to neighboring continental slope regions. Benthic biomass and abundance can be high locally on some seamounts. For example, the Scleractianian coral Selanosomilla variabilis and Brinsgdid asteroids found on the seamounts of Australia, and New Zealand. In addition, mobile pelagic fauna appear to aggregate over the summits of some seamounts, leading to elevated levels of biomass. The area to the northwest of the United Kingdom encompasses a number of seamounts and banks. These features vary in size and shape from the elongate broad summit of Rockall Bank to the more classical guyot shape of Anton Dorn Seamount. The seamounts and banks are located in an area which has been termed the cradle of deep sea biology. Did we hear there's something similar recently? Sanctuary for vulnerable Arctic species? Yeah, this sounds somehow rather similar to this. Some of the first deep water biological sampling was undertaken in this area by Victorian scientist Thomson in 1873, now part of the UK's exclusive economic zone. However, despite continued interest in this region, the hard substrata and difficulty of the seamounts and banks have presented obstacles to scientific study, and consequently they represent a major gap in our knowledge of the area. I think somewhere was something I was probably trying to show you. Maybe I don't remember. Yeah, here it is. Uh, George Bly Bank is a roughly circular feature centered at approximately 50 degrees north and 40 degrees west at the northern ends of both Hatton and Rockall Banks. The bank is approximately 75 kilometers in diameter with a summit at approximately 450 meters rising from a depth of over 1,000 meters. The moat ground the base of George Bly Bank deepens from north to south and is deeper than 1,650 meters in the south. George Bly Bank is part of the Rockall Hatton Plateau, a large piece of continental crust that separated from the northwest European continental margin around 100 million years ago. Yeah, 100 million years. What if this is totally wrong? You know, this is how they try to explain away. This is a very common thing in geology. Everything takes millions, if not billions, of years. separated from the northwest, yeah, plate tectonics. It is not volcanic, it is not of volcanic origin, and thus not recognized as a seamount under the OSPAR Convention, even though it rises more than 1,000 meters from the surrounding seafloor. I have to figure out what this OSPAR Convention is. Settled science stuff? Yeah, we agreed on this. That's, you know, doesn't make any sense. If they have corals and a huge amount of life, there must be something that feeds all that life there. So, in other words, I would suggest that there is something coming out of the ground there. Maybe special water, let's say, like this. Yeah, for example, here, dark gray rock appeared at times, often heavily silted. Yeah, silted. Possible coral fragments. Maybe it sounds very strange, me claiming that coral reefs might be very well something volcanic. Well, let me show you something. Tavertine. We are on Wikipedia. Yeah, Wikipedia is not too bad if you know how to read it. Tavertine is a form of terrestrial limestone deposited around mineral springs, especially hot springs. Yeah, it doesn't really need to be hot. It often has a fibrous or concentric appearance and exists in white, tan, cream colored, and rusty varieties. Yeah, because there's like so called impurities in the water. It is formed by a process of rapid precipitation of calcium carbonate, often at the mouth of a hot spring or in a limestone cave. In the latter, it can form stalactites, stalagmites, and other speleothems. It is frequently used in Italy and elsewhere as a building material, similar but softer and extremely porous deposits formed from ambient temperature water are known as tufa. Tabertine terraces in Mammoth Hot Springs, Yellowstone National Park. Yeah, its geothermal activity doesn't have anything to do with volcanism. Dude, no. We are living on Earth, the water planet, so we might have to recognize that the material that erupts the most, so to say, as a volcanic material, everything that comes from the ground upwards, such as lava. Everybody knows lava, yeah, it's red and hot. Maybe some know about mud volcanoes. Like I said in the beginning, clay and lava is the same stuff. Mud volcanoes, where is mud coming out? It's just very watery lava. But it doesn't need always be like muddy. Water is also a volcanic eruption material. I don't know. I have to figure out some a better term for that. But basically, wherever you have a spring, wherever there is water coming out of the ground, doesn't need to be on top of a mountain. But wherever you have a spring, it's all volcanic. If there's water coming out of the ground, it has a geothermal potential. It doesn't, like, if it's very cold water, like 0.1 degrees Celsius, it still has a geothermal potential, just a very low one. And all geothermal potential is volcanic in nature. And if we have special water coming out of the ground, it might look something like this. Yeah, there's just water coming out of the ground. Sometimes it's hot, it's steaming, but it doesn't, it, there's no need for that. It doesn't need to be hot. Calcium carbonate encrusted, growing moss in a low temperature freshwater terratine formation. Low temperature freshwater terratine formation. Warm water, cold water. Volcanic in nature, volcanic in nature. But up a Surz stepped terratine terrace formations. This terratine owes its red color terraces to iron carbonates. Yeah, this maybe is not warm at all. Might freeze over in wintertime. I think that's in Turkey. Yeah, Hierapolis in Turkey. Actually, we could check it out. I have been here checking this out some time ago. Yeah, there's water. Let's take a look at some pictures. Pamukkale. Pamukkale? Yeah, water. Obviously, it's not too hot because the people can walk in there. Yeah, check it out. Water. Mountain water. Yeah. Ever heard about mountain water? I will put a link below to my playlist about mountain water. I have been talking about this so many times. About the white rivers and stuff. There are many white rivers in the world, and I think they're all something like this. Yeah, like I said, every water spring, every place where there's water coming out of the ground is a volcanic feature. Because we are living on the watery planet Earth. That's why I think it's very important to recognize water as a volcanic eruption feature. Yeah, let's go still through this. Is there anything very interesting? Soda Dam. Yeah, that looks rather rideable. Sacré-Cœur, Paris. In my mountain water paper, I wrote about churches being actual castles or fortresses in order to protect sacred water sources because back in the days, the church had the rule that if there is anyone who wants to join the church, they have to be able to baptize him and take him into the church. And you cannot baptize anyone if you don't have water. So there has to be a source of water in every church. at least in the older ones, or elderly churches. Burghausen Castle. These are built with travertine. All right, now I get it. Yeah, but there might, I have been talking about this as well in the mountain water paper. If you build a castle on top of a hill, there has to be a water source inside the castle. If there's a war, let's say, or some tribulations going on, and you have to stay in the castle and you're surrounded by your enemies for a prolonged time, you maybe have to have water there. Otherwise, you won't stay there for long. Yeah, now we are at the beginning again. But anyway, travertine is a sedimentary rock formed by the chemical precipitation of calcium carbonate minerals from fresh water. Typically in springs, rivers, and lakes, that is, from surface and groundwaters. In the broadest sense, travertine includes deposits in both hot and cold springs, right? Cot, cot, hot and cold springs. It is volcanic. It is 100% volcanic. This is the special water. Let's go back to Google because I want to show you something interesting. Let's see if I can find it. We are somewhere here. And we have to go over here. To Rome. And even more specific, I think it's this one here. Everything. Yeah. Let me show you something. So, coral reefs are volcanic in nature because let's make just a quick recap before I show you something rather interesting. So, travertine, there is water coming out of the ground, forming these terraces made out of chalk, calcium. Where was our mud volcano once again? Epithendos, no. Borealis? Borealis, mud volcano. Octocorals. So if we have a somewhat similar water seeping coming out of the ground here at the bottom of the sea, it might form these kind of corals. Yeah, maybe with the help of some animals and stuff like that. But the principle is the same. There has to be a source for all this carbonate stuff. And this is underwater. There is more buoyancy and stuff like this going on. And if you are not under the water, it will look like this because it will flow downhill. All right? Same principle. This is how it looks on top of, like on land. This is how it forms or gets used and tries to form underwater. Coral reefs are volcanic in nature because there's less gravity pull underwater, more buoyancy and stuff like that. I really try to avoid this gravity thing, but maybe it's easier for you to understand what I'm trying to explain. But now let's go back to Google Earth. Vatican City. I think we are at the beginning of the age of Aquarius. Jesus Yeah, he's associated with a fish. He brought two fish. Yeah, because he was representing the age of Pisces. And in the big year, 1 month lasts approximately 2,150 years. And now we have 2025. And we have to add maybe 60 or 80 years, probably. Because according to some sources, he was born 60 to 80 years before we started to count our time, which would make roughly 2,100 years. So the age of the Pisces, the age of basically Christianity is over. But let me show you still something, because I think it's this one. Fontana dell'Aquilone. Let's see if we have some pictures here. Yes. Check it out. This is a tufa ditch. This is carbonate water coming out of the ground. It deposits the calcium carbonate, releases gases and stuff like that. What I've just explained to you about the corals and stuff like this. Wherever you go, like in the nature, if you see all this kind of greenery around the water pouring out, like the mosses and stuff. Let me show you just once again. Here, the mosses here around. That's a very good and easy to spot indicator of having highly carbon rich water coming out of the ground. So what does this mean? Also the color of the water, this turquoise colored water, is very easy to spot from satellite pictures as well. It is associated with the wide rivers and all these kind of things. Mountain water. Yeah, here we can see it very nicely. Yeah. Fontana dell'Aquilone. In other words, the Vatican is built on top of a volcano. Hmm. Yeah. The evidence suggests that the Vatican is on top of a volcano, and my theory of churches being actually fortresses for the water, like back in the days, I'm pretty sure there has been a source of water in every church. And many of those churches were probably built on places that were worshipped by the former or the pagan people living there. Then the church came in, built a huge fortress around the ancient holy places of the people living there, and therefore occupied the place. Let me show you still some. Maybe we can see it on this map. No, I don't know. Yeah, maybe we can see it. Here we have Naples, Campi Flegrei. Yeah, this doesn't work too well. Maybe this works better. Let's see. Yeah, this works better. So here we have Campi Flegrei. And you can see the craters and stuff. Then we go up, then we have something here. And we go up and we have something here. Yeah, I would say this looks rather volcanic in nature. And if you go just a little bit more, we have that thing here. And then there's another one here. And then there's another one here. And then there's another one here, 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 all over the place. And if you watch this picture, here's something volcanic, here's something volcanic. Is there any reason for this not being volcanic in nature? Especially when we have the Fontana dell'Aquilone. Yeah, a tufa spring. Yeah. But anyway, this is just what I think. Coral reefs or corals are volcanic features. And once again, I learned about those seamounts a bit more because I noticed this weather feature. And I could talk many, many hours about clouds being precursor phenomena for earthquakes and stuff like that. So I wouldn't be surprised if we would see an earthquake in this region south of Iceland. At the moment, I'm not too worried, or I don't expect there anything major going on at Iceland because it doesn't look like. It's just there's nothing really going on, but there is something here going on. And that's the mid-Atlantic ridge is somewhere here on the side. That's not the mid-Atlantic ridge here. Now let's have a look at, there is nothing also going on here. Where everyone is freaking out. Yeah, we could expect some more activity in southern Italy, volcanic wise or earthquake wise, because obviously something is going on here. Now let's just see where this, yeah, Naples. Yeah, maybe there is some earthquake activity increasing soon in the area of Naples. Can we observe some vortex formation here? Yeah, maybe not really. Yeah, maybe. Yeah, there's maybe something. Let's check still out quickly radar and then I will. Let you go. Yeah, not really. Yeah, that's strange. No data here. Many areas with no data. How's that? Why? Yeah, nothing too spectacular here. Basic radar beams and stuff like that, but yeah, I think that's it for now. Maybe you found it interesting. Maybe not. I don't know. It's up to you. Coral reefs are volcanic in nature, and the Vatican is built on top of a volcano. Yeah, that's it. Bye.